Imagine standing on the National Science and Maths quiz stage. The lights shining, the crowd silent, and the quizmaster asks, "State the law of conservation of mass." Your competitors hesitate, but you answer confidently, and the crowd erupts. The truth is this: champions are not made on the NSMQ stage. They are made in the quiet nights of preparation. Welcome to this masterclass inspired by the book Alchemist Code for NSMQ by Doga Wisdom Einstein. In this lesson, we will explore the philosophy of mastering chemistry, the history of great scientists, core chemistry principles every NSMQ contestant must know, powerful preparation techniques. If you are a senior high school student preparing for NSMQ, this video might change how you study forever. Stay with me until the end. The author introduces an interesting idea. He says the night is not a time for rest, it is a sanctuary for the student. Great scientists and great students share something in common: curiosity. While others sleep, great learners are asking questions like, why do chemical reactions occur? Why do gases expand when heated? Why are some elements reactive while others are stable? Chemistry is often called the central science because it connects biology, physics, medicine, environmental science, engineering. Everything around us is chemistry. The air we breathe, the food we eat, the medicines we take, even the stars in the sky. Understanding chemistry means understanding how the universe works. If you want to succeed in the National Science and Maths quiz, preparation must be strategic. Before the quiz begins, contestants often write important information on their rough sheet. This includes 1. The periodic table. The periodic table helps you quickly remember atomic numbers, atomic masses, element groups, element periods. Knowing the periodic table allows you to quickly determine reactivity, valency, bonding behavior. 2. Important formulas. Chemistry contains many formulas such as gas laws, electrochemistry formulas, thermodynamics equations. Writing these formulas before the contest saves time during the quiz. Solubility rules. Solubility rules help you quickly predict whether a compound dissolves in water. For example, all nitrates are soluble. All alkali metal salts are soluble. Most chlorides are soluble except silver chloride and lead chloride. These rules help in solving precipitation reactions quickly. Fundamental laws. A strong NSMQ contestant must remember important laws such as law of conservation of mass, Boyle's law, Charles's law, Avogadro's law, Graham's law of diffusion. These laws explain how matter behaves. Let us talk about one of the most important scientists in chemistry history, Antoine Lavoisier. Born in 1743 in Paris, Lavoisier revolutionized chemistry. Before his work, scientists believed in a strange theory called phlogiston theory. This theory claimed that substances released a mysterious element called phlogiston when burned, but Lavoisier proved this idea was wrong. Through careful experiments, he discovered one of the most important laws in science, the law of conservation of mass. This law states that matter cannot be created or destroyed in a chemical reaction, it only changes form. For example, if hydrogen reacts with oxygen to form water, the total mass before the reaction equals the total mass after the reaction. This law became the foundation of modern chemistry. Lavoisier introduced something revolutionary to chemistry: precision. Before him, chemistry was mostly observation, but he introduced accurate measurements, careful record-keeping, scientific experimentation. This changed chemistry from philosophy into a real science. Unfortunately, during the French Revolution, he was executed, but today he is remembered as one of the greatest scientists in history. Another important scientist is Jacques Charles. Charles studied how temperature affects gases. He discovered a relationship now known as Charles's law. This equation tells us something important. When the temperature of a gas increases, the volume also increases, as long as pressure remains constant. This explains many real-life phenomena. For example, hot air balloons rise because heating air increases its volume, making it less dense. This discovery helped scientists understand gas behavior and aviation. Another key scientist is Thomas Graham. He studied how gases spread through space. This process is called diffusion. He discovered that lighter gases diffuse faster than heavier gases. This relationship is expressed in Graham's law.